Today we are going to start a new topic, and that topic is slope. As you watch this video, I'd like you to fill in the note sheet that you were just given, and you're going to see the top of your sheet looks just like what you see on the screen right now. So you have your title of slope, and you have Mr. Slope Guy, which I promise will make sense in just a couple of minutes. So when we're talking about slope, I like to think of a ski slope, and if you think about the different types of ski slopes, there are bunny hills, there's black diamonds, and there's a bunch of others in between. And the reason the slopes are classified the way they are is because they're different difficulties. And the reason that there's different difficulties is because some are steeper than others. So when we're talking about slope, we're talking about how steep a line is on a graph. So on your paper, I'd like you to fill in this definition, measures the steepness of a line. When we identify the slope of a line, it will fit into 4 different categories. The first type of line that we can have is a line with a positive slope. And in order for a line to be positive slope, it will move up from left to right. We always read a graph just like we would read a book. So I start on the left side, I move to the right side, and I look at the direction that it's moving. The second type of slope we could have is negative, and if a slope is negative, then it's going to move down from left to right. So it will look something like this. If a slope is 0, then that means that my line is not steep at all. So a 0 slope is a horizontal line that runs perfectly flat from left to right. And the last category is called undefined. And an undefined slope is a vertical line, so that's running straight up and down. So please take a moment, make sure on your note sheet you have 4 coordinate grids. You should have one of these lines on each grid along with its name. So while we can classify slope very easily just by looking at the graph and seeing what direction the line goes in, I could be more specific and I can actually give a number answer for my slope. And in order to do that, we use a formula that you'll see right here, and I'd like you to copy this formula into the box where it says formula. It's the change in y divided by the change in x. And we nickname this formula, and this will make more sense in a minute, the rise over the run. So those should both be written into the box on your note sheet. And we're now going to use that formula and see how it works. So you also have on your paper a coordinate plane. You do not yet have this line, so I'd like you to go ahead and create this line for me. Please put a dot at -2, 4. So again, that's -2, 4. And let's put another dot, 1, 2, 3, at 3, -1. Go ahead and draw yourself that line so that your graph looks like my graph. When you're finding the slope of a line, all you need to know are 2 points off the line. And technically, you could choose any 2 points you want. I just went with these 2. The first thing I have to look at when I'm looking at my points is which numbers are my y's and which numbers are my x's. And we know that the first number in the pair is always the x. I'm going to put those in blue. And we know that the second number in the pair is always the y. So I'm going to put those in green. So my formula tells me that in order to find the slope, I need to find the change in y. So I'm going to take my 2 y numbers and I'm going to find the change in them, or the difference. So I'm going to subtract. And I have a choice here. I could do 4 minus -1 or -1 minus 4. And the truth is, it does not matter. Pick whatever you like better. So I personally am going to go with 4 minus -1. So 4 minus -1. Now the only part that's important, because I chose to start with the 4 for my y's, that determines where I start with my x's. So because the 4 came first, when I go to find the difference in my x's, the negative 2 has to come first. So this is going to say negative 2 minus 3. And all we're going to do is solve. So I'm going to start with the top of my fraction. 4 minus negative 1, add the opposite. We get 5. And then the denominator, negative 2 minus 3, add the opposite. We get negative 5. I'm going to simplify my fraction. I know 5 divided by 5 is always 1, and I see different signs here. So I have two ways that I could write this. I could either make it 1 over negative 1, or I could say that the slope is just plain old negative 1. And you guys decide which form you like better. That will be your slope. So now that we know how to calculate the actual slope, I want to go back and talk a little bit about why this formula has this nickname rise over run. Keep in mind that when we're talking about our coordinate plane, the line that's running straight up and down is known as our y-axis. Put a little y there. And the line that runs horizontally is called our x-axis. When you write slope, typically speaking, your final answer is a fraction. Okay, so you have 1 over negative 1 here. And what this means is this is telling me if I'm at a point on my line, how do I get to the next point? What directions do I follow? So if I look at this fraction, 1 over negative 1, the top number is the rise. And what that means is that's telling me, how do I move along the y-axis? How do I move up or down to get to the next point? So if I was sitting here, the positive 1 would tell me that I should move up 1 spot. The denominator, which is nicknamed the run, tells me how I move horizontally. When I'm moving horizontally, any move to the left is considered a negative. Any move to the right is considered a positive. So this is telling me I would go up 1 to rise, and then I run negative 1. I go left. Up 1, left 1. Up 1, left 1. So on and so forth. And if you notice, all of these points are sitting right on the line that I've created. So that is an explanation as to why our formula has this nickname. And we will work with this more in the next couple of days.